So my dear students, today I am going to perform an experiment related with this spring mass system. Okay, spring mass system. There are two parts. Number one, I'll try to find the force constant of the spring. Number two, then I'll find the value of acceleration due to gravity, small g, as well as I will verify the Hooke's law. Now what is Hooke's law? In short, very simple. If the load applied is less, then there will be small extension. If load applied is heavy, then the extension will be large. That means load proportional to the extension produced in the spring. Okay. Now replace this sign by a constant. Remember, load is less, small extension. Load is big, heavy, more extension. Replacing it by a constant sign. So load proportion is equals to numerically equals to constant into the extension. Then this K is called the force constant. The force constant is load per unit extension. So if I'm having the data with the different load and different extension, then I will plot a graph between load and extension. If this graph becomes a straight line, mean extension is directly proportional to the load. If the graph comes a straight line, that means Hooke's law is verified. So this is my aim of the experiment. So let's go to the spring. Then hanger is attached at the lower end. There is a pointer and it is a meter scale. Without hanger, pointer reading was, pointer reading was here, 33 centimeter. When hanger is attached, the pointer comes on now 32 centimeter. And what is the weight of the hanger? It is 50 grams. So that means with loading 50 grams, how much the extension is? 33 minus 32. That it is 1 centimeter. Here, this is on 32. So extension with 50 gram force is 1 centimeter. Now loading with 50 gram more. 50 gram is attached. So what is the reading? The pointer is showing. It is 31. So the weight is 100 gram force and it produces an extension. 33 it was with unloaded and now it is on 31. So extension is 2 centimeter. So with 100 gram force, okay, the extension is 2 centimeter. Now again loaded with 50 gram more. The total becomes now 150 gram force. What is the reading here? It is exactly on 30 centimeter. So 150 gram force produces an extension 3 centimeter. Now again loading with plus 50 gram more. Now the pointer it is on 29. So 200 gram force produces an extension 4 centimeter. So again 50 gram more. Now the pointer is on 28 centimeter. So 250 gram force produces an extension of 5 centimeter. So you having the data now. Now you plot a graph between the gram force and extension. And if it become a straight line, that means Hooke's law is verified. Okay. Now from that graph, you find the value of K. So what is K? You know, like how you find K? Along this side gram force, like 0, 50, 100, 150, 200 and 250. Here it is extension, like 1 centimeter, 2 centimeter, 3 centimeter, and like that. Okay, and if you are getting a line, then take a slope of this line. What is the slope of the line? For example, this is, the straight line, and okay, you call it A, B, C. So what is AB? You find what is this line, the value of this line AB. It will be in gram force, because along this side gram force. Then divided by BC. What is BC? There is an extension produced. Whatever the extension produced, AB divided by BC, that becomes K. You calculate K and write me in the description box. Then I will check whether your calculation is right or wrong. Okay. Okay, when the mass which is attached to the lower end of this spring, this mass is, 300, the weight is 300 gram force. When it is pulled downwards and then release it, then like here it is a mass. This is 300 gram. It is pulled downwards and I released it. What happened? It starts oscillating, like up and down. And these oscillation about this fixed point, okay, to and fro motion about the fixed point, it is called simple harmonic motion. Now you have to count the time for the 20 oscillation. What is one oscillation? One oscillation is, this is a mean position, mean to extreme, mean to upper extreme to lower extreme, then back to mean. It is called one oscillation. Okay, and you have to count the time for 20 oscillations. What is one oscillation? Mean to extreme, extreme to another extreme, then back to mean. This is one oscillation, and time taken to complete one oscillation is called time period. Okay, but here you have to count the time, small d. Okay, for 20 oscillation, 20 such oscillation. Either you start counting from mean, okay, like mean to like this, 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 it is 1. This, 2. Or you count like this. From here, extreme to lower extreme, then back to upper extreme. This is 1. Again 2. Again 3. Again 4. Okay, or you start like from here, like here, lower to upper extreme, then back lower extreme, like this. 1, 2, 3. Okay, there you are having the 3 choices, like 1, 2, or you are having this choice, 1, 2, or you are having this choice, 1, 2, and you to count 20 oscillation time. So for 300 gram force, I have noted the time taken to complete 20 oscillations. It is 9.8 seconds. You just verify now. Verify it whether this time is 9.8 seconds or not. And if it is true that time for 20 oscillation is 9.8 seconds, then find the time period. 9.8 divided by 20. This is time for one oscillation. Then use the formula that T equals to 2 pi under root of L upon G. Now you to find the value of G. What is L? L is the, this was the spring with some original length. But when you attach the mass, 300 gram, then there will be an extension of the spring, and this extension, if you go to back, it is 6 centimeter. For 300 gram, extension is 6 centimeter. Substituting 6 here, substituting T here, find the value of G. It comes out centimeter per second square. And calculate this value and write me in the description box. Okay, go on counting the time for 20 oscillations. Okay, as I have noted, this time for 20 oscillation is 9.8 seconds for a mass of 300 gram. Okay. Now the mass which is attached, it is 200 gram. Okay. Mass attached is 200 gram. You note down the oscillations, or the time for 20 oscillations. 20 oscillations. Again, what is one oscillation? The mean, extreme, another extreme. extreme to this extreme, then back to the same. This is called one oscillation. This is one oscillation. Okay, and you count the time for 20 oscillations. As I have found this time as 8 seconds, then you calculate the time period, 8 divided by 20. Then applying the formula, T is equals to 2 pi under root of L over G. What is L? For 200 gram force, it is, this L is 4 centimeter. Mean extension of the spring. When mass 200 gram is attached, then extension of the spring was how much? 4 centimeter. Okay, so this L is 4 centimeter. What is T? 8 over 20. Find the value of G. So just count yourself. Just count yourself the time of the 20 oscillation with the help of your stopwatch in mobile. You can. Okay. Now the mass which is attached, it is 100 gram force. Okay, and when it is pulled down and release this mass, then it starts oscillating, mean to extreme, extreme to this extreme, then back to mean. This is one oscillation, and I have found time for 20 oscillations, and it is approximately 5.7 seconds. From here you can find the time period, 5.7 divided by 20, because this time was for 20 oscillation, and this is per second now. Sorry, this is time period for one oscillation. Then using the formula that T equals to 2 pi under root of L over G. Now what is L? You know, when this mass was attached, there was an extension in the spring, and this expansion was 2 centimeter. Okay, with 100 gram force, the extension was 2 centimeter. So this L is 2 centimeter. This time period is, okay, find the value of G. And don't forget to write the results in the description box. Okay, so this is all about this experiment.